Okay, today let's build a mechanical biped walking robot that self-balances as it lifts its feet up off the ground. Just like that. Parts are all 3D printed. The original prototype is this one. And the reason I went for the shorter one is when you're moving this much mass back and forth, and even at this speed, the stopping, it may want to keep going because there's so much mass shifting. You almost need to walk even slower. When I initially built the robot, I thought everything was fine, but in the end, when I built the second one and I put new batteries in it, I found that every now and then it would tip over when that mass got to slinging from one side to the other. And it was simply that the batteries that were in my prototype were worn down enough where I was only getting about 2¼ volts instead of 3 volts. There's 2 penlight batteries in there, 2 AA batteries. So in the end, what I ended up doing was just adding it's called a diode dropper. I just took a 4001, it's a 1 amp silicon diode, and put it in line with the battery power. And that'll drop it almost 3/4 volt. So you get about 2¼ volts to the motor. It slowed it down just a little bit more. You can see the batteries go back here. I'm sorry, I said AA earlier. It's just AAA. I went with the smaller size. You could run it on just a single battery, either an AA or a AAA, and fit it in there without too much trouble. So, what started me on this, well, obviously if you're a follower of my channel and follower of what I post on Thingiverse, you know that I've been posting all kinds of different toy robot walking mechanisms that you can build. And I always liked the one that actually could lift the feet off the ground without any forks or hooks or pins or anything, and actually shift its body weight. One of the very first toys that I remember having seen as a child was a dinosaur toy, and this is actually the guts. Let's move some of these back a little. The guts of one of those T-Rex dinosaur toys, and it's a stop walk thing. It walks for a while and then it stops, and when it was stopping, what it would be doing then is be opening and closing its mouth and making a growling sound, and then it would start walking again. But what it did that was unique was the way the feet were designed. They never sat flat. It was always one to teeter one way or the other, and what would decide which way it's going to go is there's joints. It's like the wishbones in a car. Joints here that flip the whole mass of the body. So if the body is flipped over this way, then it's going to rock that way because of the way the feet were designed. There's actually 3 cams involved in this. One little one clear on the inside in there. Then the next one's on this outer rail. Then the last one's the very outer rail to get all the actions that they wanted. And we'll see if we can get it going here. So you can see how it flips the mass of the gearbox back and forth. Then the feet are going to rock because of the high point in the center. Now it's in the mode where it would be opening, closing the mouth, and making the growling sound. And now it shifts back to the walking. So this was one of the very first toys that I had seen that would work that way without the forked feet or anything. This was early 1980s, and I'm going to move the camera over to my computer screen. And so basically, I have a video up on YouTube, and I'll put a link in the description for this build so you can watch the whole thing. But this was called Bad Foot Robot, and it has 2 double LEs. As you can see, it actually shifts its body weight. It shifts its body weight at the feet though. So anyway, you can watch that whole video on YouTube and see that. I'll have the link. The next robot that came out in about 2002 was from Cube in Japan. CubeWorks was the name of the company. And this particular taller robot, which is actually about this size, about the size of the one we're going to be building today, It was only sold in kit form. It was very expensive. It was like $250 or something, and I think it was only available in Japan initially. Now this is someone else's video, but I'll provide a link to it on YouTube as well. Here, let's make this bigger so you can kind of see what we're talking about here. But it's a very slow walker because they wanted to try to manage that huge amount of body mass. And then that was called the Cam 8. And then later they came out with the Cam 10, which is a very small little robot. And since it has, and it just fell over, but since it has so much less mass, they could make it walk faster. In both these cases, the tipping action happens in the feet. Okay, so let's get back to what we're doing here today, hopefully. Pan out. It's my little build area. So I'm going to start off with, I like to use these because they're inexpensive and everyone can find them around the world. We call them the little yellow motor with the dual axle. But the important thing is you can see this one has a different gear ratio. It's the 1/120th. So this motor is geared down more so it runs slower. So if you go to buy these, try to find the 1/120th. Sometimes they'll sell them as being called TT for some reason. TT 120 gear motor. Try that search. Sometimes you can do a search for Arduino gear motor and things like that, and it'll pop up. And we're going to put it in this frame that you 3D print, which prints laying flat like this. But in order to do so, we have to do a little bit of prep to this motor. There's the standard, whatever you want to call this plastic cap that holds the motor in place. Well, we need to get rid of that, and we're going to hold the motor in place with some glue, which you can use hot glue or whatever you have handy. But basically, take those off. You'll notice one side of the gearbox has a nub sticking out and one side doesn't. When we reassemble this motor in there, we're going to want to turn it so the electrical contact sides are towards the nub side. Then the idea is to put a little dab of glue on the motor and shove it down into place. And I got my glue sitting over here. Like I say, you could use anything, hot melt, goop, whatever you've got handy. There's a lot of oil on this particular one. Sometimes they have oil on them, sometimes they don't. Oil is going to make it hard for any sort of glue to stick to this case, but that's okay. Let me just button this up, shove that down. We're going to sort of just set this aside for the moment. We'll let that set up just a little bit. Okay, there's a few other parts we have to prep, and I did a video, so I'm going to swing the camera back to my computer monitor just so you can, and there'll be a link for this in the description, but basically I just did a video on the gloop, 3D gloop for PLA. You can now get it in a tube. And here it is. And I just did a video on it, and to test, to show how well it glues and everything, I showed how to assemble the leg structures. So let's get back to what we're doing here. And these are the leg assemblies that I assembled in that video. So I suggest you just go watch that video. It's going to show you how to assemble these parts. In a nutshell though, since this is the main leg strut. It's an I-beam form. It's very thick, it's very stout because it holds the entire weight of the robot up. And this little piece has to be glued onto it like that, which you can see on these ones that have been glued. And then there's a cover piece which you can just snap on, but why not put a couple of drops of glue on it and glue it in place. And again, I cover that in that other one. It all fits down at the bottom. Everything fits flush, like so. Then into this whole thing, there's this tip linkage, which slides in there, and that should move very freely. If it doesn't, do some sanding or filing or whatever you have to do to clean up whatever mess your printer might have left on there. And I just dropped that on the floor. Okay. So once this piece is in there, there's a small piece that's going to ride on a cam, and it's got a tapered end with a 2 angle to it, and a taper end that's single. The single is going to be facing up, and this is upright. And we're going to make a left leg and a right leg, so you'll grab one of these, and it's a hexagonal fit. It can only fit in a couple different positions, but it's going to go in like that, you know, about a 45-degree angle down. And the other leg we build, this piece will angle down the opposite way, and I'll show you that. This way you will end up with a left and a right leg. And when they're there, everything should move freely. This is the only tricky part in pretty much the whole build, is gluing that small pin in without accidentally gluing this piece to this piece. So you want to be real careful with your glue. If you're using super glue, I suggest just putting from the back side a few little dot places of it, and then push the piece in from the front, and then hit it with your set spray. If you're using the gloop in the new tube, it's pretty easy because it comes down to a little teeny nozzle, and you can put the drops just where you want it. So you have those parts pre-prepped. Oh, let's see, there's a little bit of prep on the arms. The arms print flat like this on there. I have a screw sitting in it just so I wouldn't lose the screw before we did the assembly. But there's this post which prints flat that we need to glue in there. And there's nothing critical about this. You can't get the glue where you don't want it or anything. So I'm just slopping some glue on here. Okay, we'll set those two items aside, let those dry. The body will print flat on your printer just like that, no supports required. And I've already done a couple of prep steps to this body. One, the slide switch that I like to use on all my projects, so you can go back and watch any of them, is a fairly common slide switch. It's about 19 millimeters from hole to hole on the mount. And if you decide that you're going to add the LED lit eyes, you need to pre-prep your LEDs on the outside. You know, 2 LEDs, positive to positive, negative to negative. Throw in anywhere from a 100 ohm to a 220 ohm current limiting resistor on one of the supply leads, and run 2 long wires off of that. Because if you have that pre-prep, then you can reach down inside the robot body with some needle nose and push them into the eye holes to glue them in place. And you want to run your wires dead center and up in the top. Maybe use some hot melt glue or something to hold those up there out of the way, because we're going to be sliding this gearbox in there, and you don't want the wires being able to get wrapped up and caught up any of the gears. So if you decide to go with the lit eyes, make sure you glue those in first, prep the wires, pop them through, and you're going to bring the wires to the back. Now this one, I've already put the battery holder in, So I'm going to grab the taller body version. You can see here, and the wires feed through, and there's actually 2 channels on either side. The channels can be used to hide the wires. And the idea is, when you pre-prep your battery holders, you just took 2 AAA battery holders and, you know, solder a positive with a negative to join them together, because you end up with 3 volts in the end. These wires can then, when you go to glue this battery holder in there, if you first tuck the wire back into that little groove that I provided, then that's the place to keep the wiring out of the way where it can't be seen. Makes a very clean build. And then you just glue the battery holders in place. The battery door, which says Balance Walker RobotHut, prints flat on your bed like this, no supports, and it will just friction fit and stand there on the back of the robot. Oh, let's see, we've prepped that. Maybe we should go ahead and put the arms on. They've probably dried. Wondering if I should raise the camera up just a smidgen. So, with these large slots in the sides of the body, it makes it possible to run a screw from the inside to support the arms. And I haven't tried doing this. As you just heard, I've managed to drop the screw on the floor, but I think I see it. I see it, but I can't reach it with all my stuff sitting here. I hadn't thought about trying to do this in camera and get the screw in there. I'm going to try some needle nose and reach up to the armhole with the needle nose. Like so. And then see if I can get the... What I'm using here, these are number 2 self-tapping screws. You can just find any sort of screw that you've got around that might fit the armhole. Or if needed be, you can always drill this out to mate up with some screw that you've got. The key thing is we want the arms to swing free. I'm trying to get the screwdriver on the screw. I'm going to try and set the arm right onto it here, and then just simply screw it on. So the idea is it's going to hang free and be able to move. This little nubbin part that we glued onto the arm actually is going to ride inside this track for the legs, and that's what's going to make the arms move. And let's get this screw on. It seemed to work pretty good using the needle nose to get the screw up in place. So let's try that again. Like so. Got the screw coming through. So again, running the screwdriver all the way through the slot allows you to get in there. Not 100% sure that I had the right screw on this side. It's like this one was a little bit longer. But, so now we've got our body prepped. In my case, the switch mounted, the LEDs mounted, their wires, the battery holders glued in, the arms screwed on with the little pins. So now we can get back to, let's go ahead and do some leg foot assembly. There's a left and a right foot that you print, and they print flat, no supports. The shorter curved is the toe part, and the taller part here is the back. The two flat sides would be like that, so kind of envision it that way. And then you're going to take your legs. When the robot's built, this little lever part that we did will face the front, so that'll tell you which way things are going to be oriented. And these two pins are going to go down into those slots inside the feet, so you just go in sideways and turn. So now we've hooked that part, and this other part we're going to, you can run any sort of metal shaft you might have. Let me just hook this up so you can see what the objective is here. But you could use a paper clip, you could use any screw you might have around, or if you've got some metal rods or something, great. I have these little screws. These are again just some number 2 self-tapping screws, so I designed it that way so I can use this as a pivot axle. And but anything that would allow that to have that part pivot. So now you have a mechanism like this. This would be the robot, if you were taking from the robot's point of view, its left foot. And all of this should be able to move freely. And now we're just going to do the same thing with the other foot. In order to do that, I need a couple more screws. There we go. They didn't need to be this long. It's just the first ones I grabbed. Hopefully they're not too long. Yes, I could have pre-prepped some of this to save time, but I don't know, I kind of thought you might want to see it so you know exactly how it all goes together. So, now we have the robot's right foot. Like so. So now let's get back to our gearbox, I think. In the gearbox, we've got 4 main large gears. And the ones that do all the magic are actually marked with an R for right and an L for left, so you know what's right and left. And all of these gears, and we'll see if this shows up in the camera, there's a couple of little circles there with a line through the middle. We're going to mark that tooth so we can find that center. And then up at this end, there's a little teeny hole divot there. We're going to mark that tooth. See, on this gear I've taken a small black pen and followed that. We need to mark those points so that we can actually get everything timed out right, lined up right when we assemble it. And this black pen is going to make it easier for this to show up on camera. I mean, you don't have to use a black pen when you're doing it yourself because you'll be able to see it. We're going to need to be able to hold these gears onto this gearbox frame. In my case, I'm using a number 3 by 12 screws. But again, there's nothing special about this screw. Find yourself a screw that'll fit through the gear without binding. See, it's kind of sloppy, it's not even really important. And that you can secure into the frame. That's really all it comes down to. Now, locating the right gear on the correct side of the frame. Well, when this frame is installed in the robot, this flat side goes to the front. Okay, so that means if you were standing as if you were the robot, this is the left side and this is the right side. So this is my left gear. It's going to go on here. This isn't really the right screwdriver for those screws. Let's try this one. Yeah, that fits much better. I like to tighten them all the way down and then back them off until things spin free, till you know there's no binding. Okay, we might as well put the right side one on. All the way down, back it off. Okay, then there's two large top gears, and in both cases they're both the same. There's no left or right to them. So we'll just screw those in on. Again, take them all the way down. Back them off till you get free movement. Like so. Okay. So you should have a frame that looks like this. All these double hole notch things. This is the bottom where the cams are. This up here is the top. Again, to make it easier to orientate, these mounting holes are where the body screws in. The distance between the hole and here is greater. So if you're trying to find the bottom, if you're a little confused, look for the one that's got the most there. Okay, well, let's go ahead and prep our motor a little bit more. We have these two motor gears. They both print down, and you could just slop a little bit of hot melt glue or some other glue on the inside of the gear and then jam it on the shaft. But again, since I have some small number 2 screws, I go ahead and just screw them down. They're keyed, so you shouldn't be able to put them on wrong. And the gears themselves have these deep alignment slots, which we're going to use to try to align everything up. Kind of turn this like so. Now the motor parts, this is the right side. This is just the way I like to put it together, so if you're trying to follow the same wiring procedure and everything, the motor's going to slide down in the frame like that, and it just sits in there. See how it just drops in place? We don't need to glue the motor in or anything, because once it's slid into the body's going to touch the part of the motor here and touch this, so it gets held in place. This is going to make it easier to try to align these gears, which is what we're going to try to do right now. I'm going to turn that motor a little bit more. So just by lifting the motor and lifting the gears, you can try to get things lined up. It's easier if your motor is rotated into a position where you can see it. So this side, I've got both these dots at the top. I've got that black dot lined up into that gear. I've got that black line lined up into that slot. Now let's try to get the other side lined up. But in this case, since we had both these top, on this other side we're going to want both of these cam nubs, whatever you want to call them, down. So let's rotate this around like that. There's one down. And there's two down. Sounds like my dog wants outside. Hang on. Sorry about that dog break. You gotta take care of your friends. Okay. When you're moving everything around, it's gonna probably mess up one side or the other. So you just kind of keep fiddling with it till you get them back. You don't even want to be off one tooth if you can help it. So everything's lined up on this side. Both drives are down. Everything's lined up on this side. Both drives are up. So I think that's good to go at that point. I suppose one thing I could have done, because there's a chance that we may mess up the alignment, is pre-solder tinned those motor tabs to make it easier to hook onto later. So why don't we just do that now? Get some solder here. I'm also going to take a red wire and I'm going to go ahead and put a red wire on this front. Remember, this is the front of the robot, and because that's going to be hard to get to later, whereas right now we can kind of get in there. So kind of get those tinned up, because it'll make soldering things on a lot easier later if everything is already pre-tinned. Okay. Get my soldering gun up here where we can get to it a little bit easier. Alright. So, there isn't a whole lot left here to do. Just try to hold it so everything stays lined up right. So you know this is the front, and you know this is the front of the foot. You should be able to take it and then place a leg on there like that. You should be able to take the other leg and put it on there like that. And then a little bit of luck. Remember, that flat side is going to go to the front. We should be able to try to work this whole assembly. Oh, and we have to watch the arms, because they have to fit into those slots. Ew, let's see here. Here's one. Remember those little knobs that we had on the arms? Now that the legs are coming up in place, make sure you feed those into those I-beam legs. There we go. And everything should just keep sliding up in there. When we watch from the front, we should be able to see when the holes appear for holding the body in place. And again, I guess I need to get myself a couple of small screws. Again, you could pre-find almost any screw for this since it's just holding the body in place. You might have some little wood screws or something laying around. But, again, like I said, since I have the number 2 self-tapping screws, that's what I used. And there's just 2 screws, one on the mouth and one between the eyes. And once we get those in place, we should be able to take a look at it here with the camera a little bit closer. Make sure that we got our arms within the I-beams for the legs. That's good. And all of this stuff. That's good. So now all it really comes down to is soldering up a few connections. This red wire that we put on the motor, I'm going to bring, see which way that might look best in the camera. I'm going to solder to one leg of the switch, and then our battery wire and positive LED wire. Both of those wires are in here somewhere. I should be able to pull them back up where we can reach them. So we'll solder the battery wire to one side of the switch. We solder the motor to another place of the switch, and the LED one, and we've got our negative for the eye LEDs and the negative from the battery. They're going to solder on this back terminal of the motor. And I don't know that I can do this and keep this stuff in frame, so that's kind of why I was explaining it to you here. We'll give it a shot though. I mean, if it's on camera, great, and if it's not, I can see it. I don't know if you can. So there's the negative wires. Let's pre-tin. Looks like we need to pre-tin the battery wire. I'm going to need to hold on to that with something. You know, as if it isn't awkward enough trying to solder this kind of stuff on your own, but trying to solder it and keep it in frame, pretty awkward. So I think at this point I'm not going to worry about it. I'm going to just hold this contraption on my knee and solder this on here. Otherwise we might be here all day. There will be plenty of room. See if we can get this in the camera angle. Back here behind the motor where my finger's pointing, where you can tuck wires, where we can cable tie things together and tuck them to keep them out of the way of the gears. So don't worry about excess wire length. We should be able to wad it up somewhere. So I'm not going to worry about the fact that that LED wire is really long. I'm going to leave it long because I'm sure we can coil it up and put it someplace where it's safe. What I just did there is I've twisted the LED wire and the red motor wire that we soldered on earlier together, so I can solder them both on at the same time to the power switch. It's just a question of getting my fat fingers out of the way and the soldering gun, or soldering pencil in this case, in there. Okay. Like so. There's also room in this switch box area where wires couldn't be pushed in, since that's all hollow. So you could store the motor wire, for example, down in there. Maybe even the LED wire. Let's try working it down in there. think a flat blade screwdriver could be used to push those down, like so. But in the end, what you'll probably want to do is cable tie them to keep them out of the way of the gears. But basically we're done. If we've wired things up right. If we haven't, it'll be running backwards, which will be a problem. So then you go to the dollar store and you pick yourself up some of their cheap heavy-duty AAA batteries. Sunbeam heavy duty. Never buy their ones that are say for light duty, because there's just nothing in them. I mean, what are you ever gonna use a light duty battery for? I don't know. There's one in. There's two in. There's the battery cover. Now let's see if the motor is running the right direction. Yes, it looks like it's going to be. So, let's clear an area here. Let's tip this up. And see what happens. Oh, and this will be running on the full 3 volts. This motor hasn't been reduced with the diode and speed yet, so we can actually compare this one and this one. This one may tip over, because like I say, it's moving all of that mass, and it may be too much. It may flop on over. But it looks like it's doing okay. So that's running on the full 3 volts. And here's one that's running with a diode reduced speed. Whoa. So you see, it makes it a little bit more stable because it's a little bit slower. I don't really have enough room here to show you all this without bumping into each other. But you can get the idea. What happens is, in order for it to work, when they're lower, this foot has to tip down to kick the body over. Then the body will rest on that foot till it comes around to the next position. So it basically does a kickoff. And worked quite well. So, I'll have the files up on Thingiverse so you can 3D print it. And with this build video, hopefully you build one. It's actually not a hard build. And here it is from the back. I don't know if we've even done a back view. So check out the other videos if you want to see the Bad Foot robot that really inspired this. If you want to see the Cam 8 and Cam 10 robots. If you want to, well, I guess you've already seen the dinosaur one. But they all are a little bit different in how they work. This is a little bit closer to how the Cam 10 is operating. But it has the body shift happening down in the foot, like in the Bad Foot by TOMY. So there you go. Hope you enjoyed.